So in this demo, I'm going to show you the latest features I added to my regression analysis web application. I've recently enhanced the tool with new functionality for hypothesis testing and confidence interval analysis, allowing for deeper insights into our regression models. So I am going to put the sample size of 50, the mean of 0, a variance of 1, a true intercept of 2, a true slope of 1.5, and the number of simulations is going to be 50. So I actually already generated the data. So when I press generate data, it actually produced this plot. And we see a regression model, and the regression line we obtain is y equals 1.57x plus 1.87. And now we can move on from the scatter plot to the generated histogram of the slopes and intercepts using 50 simulations. So again, the observed slope was 1.57 and the intercept is 1.87. The overlapping histograms show the variability in the slope and intercept estimates across different simulations. This helps us understand how consistent our estimates are. And as you can see, with the overlapping blue and yellow, those are the overlapping histograms of slopes and intercepts, with the blue being the slopes and the yellow being the intercepts. Now let's move on to hypothesis testing. I will select slope as the parameter to test and not equal to as the test type, which means that we're performing a two-tailed test. So let's scroll down to the results of the hypothesis testing. So in this context, we're testing whether the observed slope of 1.57 is significantly different from the hypothesized slope of 1.5. And as you can see, this is the results. We get a p-value of 0.9, which is much higher than the common significance level of 0.05, and a p-value of 0.9 indicates that there is very little evidence to suggest that the observed slope is significantly different from the hypothesized slope of 1.5. So in other words, our observed slope is consistent with the hypothesized value, and we fail to reject the null hypothesis. And this is obviously very clear since 1.57 is very clear to 1.5. So now let's move on to the confidence interval analysis. For this, I'm going to choose the parameter to be slope and the confidence level that we're testing to be 90. And then I'm going to press calculate confidence interval, and then we're going to scroll all the way down to the results. And the confidence interval we get for the slope is between 1.48 and 1.7. And the mean estimate is 1.59. And since our hypothesized value of 1.5, as well as our true value of slope value of 1.57 falls within this range, and because we can be reasonably confident that our model's estimate is accurate. And this shows that with 90% confidence, the true slope lies within this range, which means our regression model is reliable. So, yeah. So, in conclusion, the new additions to our web page, including the hypothesis testing and confidence interval analysis, gives us a deeper understanding of our regression models. We observed that even with a small sample size of 50 simulations, our slope estimates were consistent with a tight confidence interval that includes the true value. Additionally, the high p-value of 0.9 in our hypothesis test indicates that our observed slope is very close to the hypothesized value, suggesting strong support for the null hypothesis. And these features makes this this application highly useful for statistical analysis. Thank you.